What's up YouTube? It's me again, Arwil Nathaniel Ramento Alfonso, and in this lecture video, we are going to talk about an introductory topics to one of the topics in inorganic chemistry, namely the molecular symmetry. So, you need the foundation of BS EPR theory before you diving in into this topic. Kasi we are dealing about the 3D molecular structure and its corresponding symmetry. Okay? So again, if you wish to go directly at the practice exercises, kindly skip this video and go at the part 2 of this lecture video. Okay? So let's start. Now, the outline of our lecture video, in this lecture video, of course, first and foremost, introduction, then symmetry operations, symmetry elements, the successive operations, of course, the gist, this topic, the point groups. Ayan, after we discuss the symmetry operators and the successive operations. Then an introduction to character tables and vibrational spectroscopy in relation to point groups and character table. Okay, so these are the outline. So the symmetry, of course, symmetry is exist in nature. We can see it at the butterflies, starfish, and sa ating streptococcus bacteria that they exhibits a symmetrical features when you cut them in half, right? So we also humans are also symmetric. Bakit? Why do I say that? We are bilaterally symmetric kasi kapag hinati tayo sa gitna, 'di ba? Tayo ay may dalawang mata. Tayo meron dalawang kamay, dalawang paa. At yun sa gitna, parehas lang din. Ngayon, ayun, so wala may kitang taong iisa yung mata, 'di ba? 'Di ba? So we are bilaterally symmetric but not exact in terms of facial features, of course. Ayun. So what the point that I'm trying to make here is that symmetry exists in nature. This also exists in humans. But in chemistry, it is also significant. This is where it comes interesting because it is important at dun sa molecular level ng mga crystalline systems natin. By using Raman spectroscopy, we can determine the crystal we synthesize. But that is an advanced topic. We are dealing in introductory part, okay? And the molecular symmetry is also essential for the construction of molecular orbitals. That I think that's symmetry adapted linear combinations, which is not the scope of our lecture video, of course, because that is an advanced topic. And also, we can also determine or predict the number and types of vibrational peaks na mag-appear after analyzing that particular molecule in the IR and Raman spectrum by determining the point group, di ba? That is interesting. But before we discuss all of that, isa-isahin muna natin ang mga essentials topics natin dito sa ating molecular symmetry. So, unahin natin yung the operations and the symmetry elements that use, okay? Ang working definition ng symmetry natin is the operation to form an object that lives in a configuration that is indistinguishable from its original configuration. For example, in this boron trifluoride, so bakit kaya 120 degree ang rotation dito sa ating boron trifluoride? Because as per base EPR theory, di ba, the bond angle between this is 120 degrees. So again, you need a strong and solid foundation for the base EPR theory before you dive in this topic. Okay? Ni-repeat ko lang. So upon rotation, nag-label tayo. We label this, okay, the red fluorine. Upon rotation, ayan, indistinguishable pa rin siya. Then upon 120 degrees rotation, indistinguishable pa rin siya. So this book only highlight the red to determine that. Okay, kung ipapakita ko, let's say this one is the boron trifluoride. So I just use clay lang pala. I'm sorry for that. Kasi wala akong molecular models for that. So nilagay ko use clay and ting-ting na natagpuan namin sa aming bakuran. Ayun. So, but what I'm trying to say is, ito yung boron trifluoride natin, right? So, this is one, yan. When we rotate this by 120 degrees, distinguishable ba siya after rotation? Diba? Hindi naman, di ba? Then, rotate ulit natin. Okay, assuming the band angle and the band length are, ayan, identical pa rin ba siya after rotation? Hindi, di ba? So, this one, meron siyang symmetry operation that can occur that is indistinguishable from its original form, right? So, uh, and we also have the term pseudosymmetry, na which is the apparent symmetry in molecule that comes to resemble. Kasi when we substitute the hydrogen from fluorine, hindi na mag-e-exact yung bond angle niya in a BSEPR theory, but however, it is always a trigonal planar pa rin. And the same operation can only occur to, pero ayun, it's just a pseudosymmetry, but again, C3 is not the operation that we're going to perform him, okay? So, the summary ng mga symmetry operators natin are this. We have this symbol Cn. So, these are the symmetry operations, the symmetry element, and their corresponding symbol. Rotation, okay, Cn. This is actually italicized. For the reflection in the mirror, we have sigma. Actually, we have 3 times. We have sigma b, we have sigma h, and sigma d. And I, this is actually a small, sorry for that. And the improper rotation. So, ang nangyari ito is n-fold rotation, followed by reflection, then if it is indistinguishable pa rin, or yon, that is an improper rotation. Then identity is just a not performing a operation. It will not change the configuration of the molecule. It's just as it is. Okay? So, isa-isahin natin itong mga to. Isa-isahin natin. First and foremost, the rotation about the n-fold axis of symmetry natin. Okay. So, this is the typical formula of the angle of rotation. So, bakit kaya 120 degrees? So, this is the band angle kasi. Ayan. So, in general, ang formula natin for this is, dito ko lang ilagay, n is equals to 360 degree, that is fixed, all over the band angle. Okay? The band angle. So, in the case of our boron trifluoride, it's 120 degree. Therefore, the n is equals to 3. Therefore, ang n-fold axis of symmetry niya is C3. Okay? C3 ang n-fold axis of rotation niya. Kapag na-rotate natin ang molecule, dito. Ayan. So, pero, it also contains a C2 rotation. 180 degrees rotation. So, nasan kaya yun? Bakit meron? If you would notice, in this, nandito ang mga C2 operations natin sa mga terminal atoms niya upon rotation to 120 degrees. At tatlo yung mga yon. So, upon studying molecular symmetry, kailangan kaya niyong i-visualize yung movement ng molecules natin in a space. You need to have a vast imagination. Okay? So, if that can't help, you can utilize using a model. So, again, meron daw tayong C2 rotation. Nasa ayon? Dito. Kasi kanina, what we done is C3 operation on the plane, dito sa gitna, di ba? That is indistinguishable. Now, if you rotate this, dito yung tusok natin sa may molecules here. If we rotate this by 180 degrees, indistinguishable. Distinguishable pa rin ba siya? Hindi na, di ba? Again, rotate this again. Distinguishable pa rin ba siya? Hindi, di ba? And then isa pa, dito sa part na to. Okay, dito. Rotate. Distinguishable? No. So, therefore, it contains a C2 axis. Ang point ko lang dito, guys, is alam nyo dapat kung saan tutusok. Okay? Kung dito ba, dito rotation nyo, or dito, pag ganyan. So, you need to use that. Okay? And then, we have this term, principal axis. That is the axis with the highest value of n. In the case of our boron trifluoride, our principal axis is the C3. Ito, guys. You can see here. Ayan, no? So, ito yung mga axis kasi natin, n-fold axis of rotation. But our principal axis is the C3. Okay? So, we have the symmetry elements. Ayan na. Dito, yung C3 and C2. So, dalawa symmetry elements or operations na perform natin in a boron trifluoride. So, another example, the xenon tetrafluoride. Ayan. So, ano kaya yung ating principal axis dito? So, we have C4 and C2. Principal axis is C4. So, bakit kaya ulit ganun? Kasi, di ba, ang N natin, if you calculate that, meron tayong 90 degrees. Okay. Bakit kaya 90 degrees? Okay, I have this, I made it again. Ito. So, this is the XE, di ba? Square planar yun, right? In a BSEPR model. So, paikutin natin yung molecule. Let's not base dito sa ating napag-usapan dito. Okay, wag pa ganyan. But rather, i-flip natin. Ayan. Diba? The angle between this, using, syempre, gamit natin ang protractor, is 90 degrees, right? So, ang tusok natin dito sa molecule, rotate. Okay, distinguishable ba? No. We rotate again. It is again indistinguishable. It is also have C2. Dito, ang tusok naman natin sa part na to. So, rotate ko. Distinguishable ba? Hindi naman, di ba? Dito itusok natin. Rotate natin 180 degree. Distinguishable? No. Okay. Therefore, it contains a symmetry. Remember, the operations that you need to take is dapat ay indistinguishable siya into its previous original configuration for it to be considered a symmetry operation. You cannot rotate this by 120 degree. Kunwari, rotate natin 120 degrees, magbabago yung orientation niya. And it is not, di ba? So, we cannot do that. Okay? Cannot do that. Kasi nagbago na yung shape niya dito eh. Upon rotating it into another angle. Dapat ma-retain niya yung original configuration niya. So, ayun. Kailangan nyo talaga ng vast imagination for this. Okay? So, again, self-study exercises. This will be done on the part 2, our lecture. Ayan. So, second symmetry operation natin is the reflection through a plane of symmetry. What do we mean by that? So, meron as tayong mirror plane in a symmetry natin that can be indistinguishable. Such as what we can see in this boron trifluoride, diba? So, this is the molecule. Ito yung salamin. Yan. Hahatiin natin siya sa gitna. Pero depende kasi yun. Okay? You need a vast na imagination for this. So, sigma H refers to the is the mirror plane perpendicular to the principal axis. When we say perpendicular, ganyan yan, di ba? Perpendicular, lines that meet, parallel, ganito. Yan, di ba? That is the orientation for that. Dapat perpendicular yung plane niya. So, that is considered as sigma H. In this case, sa ating boron trifluoride, it contains a perpendicular plane kasi, yan, it contains, ito yung principal axis of rotation natin. This is the mirror plane. Ayun. And then, the sigma V refers to when the mirror plane contains the principal axis. What do we mean by that? Okay, ganito na lang ang ano natin. For this one, in the case of water, ayan. Boron trifluoride muna tayo. Boron trifluoride, pahiga natin. Then we have a mirror plane. Let's say this paper. Hati natin siya sa gitna. Then ang principal axis ng mirror plane natin is perpendicular, di ba? Pag nirotate mo siya into 180 degrees. So, this one is considered as sigma H. Ito mirror plane na to. However, in the case of water, ang principal axis natin dito, di ba, is dito. Kasi pag tinusok mo siya dito, wala naman siyang C3 principal axis or and so forth. Just contains C2. And then, ang mirror plane lang natin dito is this one, di ba? Hahati siya sa gitna to be identical to its corresponding mirror images dito sa gitna. Hatiin mo siya sa gitna. And then, the principal axis is contained on the mirror plane. And that is considered what you call the sigma B. Sigma B. Sigma B contained sigma H when it is perpendicular. Okay, always remember that. Sigma H and sigma V. And we also have a term, the sigma D, na that is quite complicated kasi it needs to bisect between the two adjacent twofold axes. For example, in the case of boron trifluoride. Sa boron trifluoride natin, we have iba dito, sa boron trifluoride natin, it also contains symmetry element of sigma V. Why? Ito yung plane natin. Ito. Hindi ko kasi maano. I'm so sorry guys. Ito yung plane natin. This one here. So, hatiin natin. Mapapansin niyo it is the other side of the mirror is also identical to the other side, right? So, it also contains three. Meron dito. Meron dito. Diba? Try to imagine. Ayan. Try to imagine this one. Also contains in this one. So, kapag yung may sigma D tayo, for example, you have this plane, saan kaya magpa-bisect? I'm just gonna use this PowerPoint. Ayan. So, we have this sigma V. Ayan, dito between the three. And then, ang sigma D natin is kapag karoon ng bisection between the sigma V angle. Okay? Kapag in illustration ay ganito. For example, this one is sigma V. May dalawang sigma V dito. Where's the paper? Ayan. Sigma V on the trigonal planar. And then, syempre, upon that, dun siya sa gitna. Ayun. So, I hope you get it kasi ang hirap to illustrate with you using just an improvise. But I hope your professor will explain it further to you. So, that's it. That's the concepts that I'm trying to make. And then, so therefore, we have three. Ayan. So, these are the definitions of the mirror plane. So, tatlo yung elements niya. We have sigma V, sigma H, and sigma D. Okay? We're done with the two elements. Punta tayo dun sa ikatlo. But these are the self-study exercises. So, if you wish to know this, go directly at our part of the lecture video. Okay. The third symmetry elements is the inversion center I. So, the working definition is if the reflection of all parts of molecule through the center of the molecule produces an indistinguishable configuration, or the center is the center of symmetry. It's called the center of inversion, denoted by symbol I. Okay, to illustrate, let's have this molecule. So meron tayong mirror plane here. Diba? Ayan. Mirror plane. We have a mirror plane. So, let's take this only. Try kunin natin. Disregard natin to. So, itong molecule na ito, this is the center of inversion. Ayan, this is the I. So, upon reflection here, it is indistinguishable, di ba? Na-retain yung molecules niya. So, therefore, this is contains a center of inversion. Now, for the other, this is where the weirds come in. Ito does not contain a center of inversion. Why? When we place a mirror here, di ba? Inversion, inverted. It does not say the other part, di ba? Let's get this part and disregard this one. So, ito yung center of inversion. Ito yung center niya. However, upon inversion of this molecule, hindi naman siya nag-produce ng another molecule just like this, di ba? It does not identical to its original configuration. So, this one does not contain a center of inversion. How about this molecule? Does it contain a center of inversion? Okay. We have a mirror. So, let's get this one and disregard this one. Center of inversion, this one. So, ang inversion niya ay saan? Dito. Diba? We are not talking about mirroring it, but rather inverting it. So, upon drawing its inversion, ganito dapat itsura niya. Naging linear. Kaparehas dito. Does it the same configuration as the original molecule? No. Therefore, this one does not contain a center of inversion. Okay? What about this one? Benzene. Does it contain a center of inversion? Let's check. Place a mirror plane on the middle. So this is the inversion. Okay? Let's get this one and disregard this one. Will it retain to its original configuration upon inversion? So this molecule, remember, not mirror images, not mirror image, remember, but rather an inversion. So ito, inversion contains a molecule. Ayun. This one also contains an inversion. This one also contains an inversion. So this one contains a central inversion. Remember, ang inversion baliktad. Mirror images, ito. Ang mirror images nito ay ito. Ang inversion nito ay ito. Tandaan ninyo not mirror images, but rather an inversion. What about this molecule? This one is octahedral. Does it contain a central inversion? Okay, let's place a mirror on the center. And is this the center of inversion? So, does the molecule contains center of inversion? Yes. Kasi, ang inversion nito contains also here. This inversion molecule contains also here. And this one also contains here. An inversion, diba? It retains its original configuration. Therefore, this one contains an inversion. Next, what about this tetrahedral? There's some mirror images. So, this is the center. Okay. Disregard. Let's get this one. And disregard this one. Center of inversion. Let's draw a molecule here. And then this one, draw a molecule here. Does it retain a center of inversion? Parehas pa rin ba siya? After performing. Diba wala? No. Hindi siya identical to its original configuration. Therefore, this one does not contain center of inversion. Okay? So, I hope you understand that. And let's go at the improper rotation. The working definition is improper rotation. Excuse me. Is that ito principal axis and fold rotation followed by reflection. Okay. Rotation followed by reflection. For example, this tetrahedral. Ito. The methane. Ibahin natin yung orientation niya. Ibahin natin yung orientation. So, this one has a principal axis. This one. At ang angle between here, dito, is what? 90 degrees. Sir, bakit 90 degrees? If we take a look at the top view of this molecule, ganitong itsura niya. Yan. Yan yung top view ng molecule natin. Ganyan yung itsura niya. So, ang angle between here is 90 degrees. Then, upon rotation, diba? So, mag-rotate tayo here. So, remember, imagination, guys. Ito yun. This is it. The molecule niya previously. 90 degrees of rotation. Teka lang. 90 degrees of rotation. 90 degrees lang. Ayan yung naging itsura niya. Diba? The same also here. Ayan. And then after performing, mag-perform tayo ngayon na reflection. So, identical pa rin siya, diba? It is indistinguishable. Right? Bakit kaya ganun? Kasi, when you reflect this one, magiging ganito siya. And when you reflect this one, magiging ganito siya. Which is also indistinguishable to its original configuration. Diba? So, it contains an improper rotation. And ano yung N natin dito? Ano natin yung degrees natin, diba? N is equals 360 degree all over band angle. And the band angle is 90 degrees. Therefore, it is 4. Therefore, this methane is S4. Contains an S4 improper rotation. Okay? So, for the practice exercises, ayan, tignan nyo na lang in the part 2 of our lecture video. Kasi pure discussion lang tayo dito, okay? Next, the last operator ng ating uh, molecular symmetry is the identity operator. It leaves the molecule unchanged. Okay? Wala kang i-perform na kahit anong rotation or axis dito. So, upon performing here the E operator, that's it. Boom. Yun. Ayan. To illustrate, ayan. Ito. Perform identity operator. Boom. Ganun pa rin. But when you perform a C3 operation, rotate mo siya. Rotate mo siya. Performing a C2, a C3 yan C2, ganyan. Maganyan. But performing an identity operation, boom, boom. And so that is the four natin summary for our rotation. Okay. Remember, this is italicizer. For that, this one is small I, italicize SN. Yan. So, self-study exercises tayo. That's the part 2 of our lecture. Okay. Then, ayan. Dalikan lang natin. These are the operations. We have rotation, we have n-fold symmetry axis, mirror plane, ano ulit yung tatlong mirror plane natin, sigma V, sigma H, and sigma D. Itong N is determined by N is equals to 360 degree all over band angle, and for that. So, these are the symmetry operations natin. And then, successive operations on the part 3, it's just this one. Let's say we have an ammonia. Okay. So, the band angle between them dito, tanggalin ko lang to. Wait lang, guys. Ammonia. Tanggalin ko lang to. Ayan. This is the ammonia. Diba? The angle between here, dito, sa ammonia natin, is 120 degrees. Then, upon performing a 3, using a C3 operation, to leave it indistinguishable to its original configuration or previous configuration. So, performing that 3, ayan, it will yield back to its original configuration. So, we perform 3, C3, and then, of course, siya ay naging identity. Sir, bakit po naging identity? Kasi, di ba, ang identity, performing, leaves the molecule unchanged kung jump in ka dyan. Di ba? It leaves unchanged. And it is equivalent to identity. Okay? Identity natin. Now, ito na. This is where the gist, or ito na yung pagsasama-samahin na natin yung mga symmetry operators and elements natin to determine the point group of a molecule. Pagsasama-samahin natin yan, the n-fold operation, the mirror plane, the improper rotation, and the identity. Pero usually, ang nangyayari lang is the n-fold and the mirror. Okay? So, point group, ito yung number of symmetry natin, or the nature of the symmetry elements of the whole molecule. So, the typical example, if you discuss ng professor ninyo, mayroon kayo makikita C2, C3V, D3H, D2D, TD, OH, and IH. So, what are those? So, saang classes ng point groups kasi natin? So that we have C groups, we have D groups, and special point groups that contains many symmetry elements. Kaya they are often classified as TD. This one is tetrahedral. Ayan, kapag tetrahedral yung 3D molecular structure molecule, the OH is octahedral. Octahedral. And this one is icosahedral. Ayan, icosahedral. Ayan. So, we also have this one, mga typical point groups natin in this. For example, C1. Diba? C1. Bakit C1? Kasi 360 degree. Diba? 360 degree. Over 360 degree. Kasi, does not contain any C2 or C3, di ba? It has 4 different substituents. Kapag ni-rotate mo to, for example, into 90 degrees, it is distinguishable into its original configuration, di ba? So, kunwari, itong molecule na ito ay mapupunta dito. Yung molecule na mapupunta dito, yung brown, ayan. In short, it is different to the previous configuration. So, ano lang ba pwede natin ito? I-rotate mo na 360 degree. That is C1 point group. So, we also have a C infinity V point group. So, bakit kaya ganun? Kasi, ang principal axis natin dito, hindi naman dito, di ba? Dito, ayan. Dito yung principal axis natin, that is linear. Dito, iikot mo into its infinity, non-stop, ayan. So, infinity ikot niya. It cannot be C2 or C3. So, parang ganito lang yan eh. Wait lang. Parang ganito lang yan. So, just gonna dissect one of the molecules here. Ganito yung tsura niya. So, wala siyang C2. Kasi, ito, distinguishable na. Yung blue napunta sa right. Yung brown napunta sa left. So, ang kanya dito yung tusok natin. Principal axis is here. And, iikot-ikot lang siya ganun. So, bakit may V? Kasi, it contains a sigma V plane. Sir, bakit sigma V? Hindi sigma H. Kasi, it contains the principal axis. Diba? It is not perpendicular. Otherwise, it is sigma H. Okay? So, let's get back. So, what about this one? The infinity H point group. The infinity H point group is symmetrical to each other. So, meron kasi siyang principal axis. And it also contains a sigma H axis. For example, in the case of hydrogen atoms. You just notice. So, di ba? We have principal axis here. Dito. Ayan. So, mapaikot-ikot mo siya. Also, principal axis here. Rotation into its 180 degrees, di ba? If mapapansin ninyo, we have nagkaroon tayo ng bisection between two principal axes. Pag nag-bisect into its perpendicular, this is considered as a D-symmetry element natin. D-symmetry element na to. Pag isa lang, C, pero pagka nagkaroon dito, it is D. So, since we have a D, also the principal axis C2 contains a perpendicular to this plane here, sigma H, di ba? And we have also a infinity. So it is classified as the infinity point group in the case of this. Okay. It's also same on the other side. Ayan. So ayun. So the TD and OH point group are this one. Ayan. We have tetrahedron, we have octahedron, and icosahedron. So it is only possible, let's say for example, ayan, yung H natin, methane, perhaps. Ayan. It is only true for all of this if and only if they only contain same bonded atoms to each other. Ito, it is TD. Pero let's change the one substituent or bonded atoms. Kunwari, Cl. That is not a TD anymore. Kasi we have dito yung principal axis natin and then we have C3 principal axis. It is C3V point group natin. Diba? Ayun. So, my point here is this point group classification is only possible if and only if they contain the same atoms. So, in the case of tetrahedral, it is XY4, octahedral, XY6, and icosahedron, ganun din, contains same terminal atoms. Okay? So, ang determination ng point group natin are this one. Okay. Remember, ha? Remember. Always remember, dito ano tayo. So, ano yung for operations natin? Mirror planes, ah, mirror planes and fold axis. So, pagka nagkaroon tayo ng, we have a perpendicular upon the 2. So, we have a d-axis for that. D. Pagka nagkaroon ng bisection or nag-bisect perpendicular, yung ating mga axis natin, that is D. Pero kapag kung ano, kunwari for example, this one is C3, this one is C2, ang kukunin nyo is yung higher principal axis. So for example, ayan, D3, okay? And then for the mirror plane, natin yan kasi we are going to combine all of the operations natin. So that is discussed in the part of the lecture video. Ayun. So these are the schematic diagram. We are gonna use this. So for example, start here. Is the molecule linear? Yes. So ano kaya? C infinity B or D infinity H? Ayan. Kapag no, ayan, is it tetrahedral, octahedral, or icosahedral? If it's yes, then assign. Kapag no, what are the principal axes? Is there a mirror plane? Ayan. So, what I'm trying to point is, we are going to use all of those symmetry operations for us to determine the point group of a molecule. Okay. So, these are the self-study exercises. So, this is discussed in the part 2 of our lecture video. Okay. So, if you wish to have more knowledge, kung gusto nyo ma-practice, you can visit this site, simotar.org, na kung saan you can practice, just practice, symmetry challenge. Ayan. Ayan. Just punta nyo sa site na to, and you will see a different vast molecules here na pwede ninyong paikot-ikutin for you to determine its point group. Ayan. I just introduced this. By the way, this was introduced by my professor at the University of Santo Tomas, Dr. Carlos P. Garcia. Hello, sir. Ayun. So, okay. So, with that, ayan, we also have character tables. And the classification of our character tables ay construct to according doon sa, depende sa point group natin. Ito ay useful sa vibrational spectroscopy. Now, to start with, itong nandito, ano lang natin pa isa. This is the point group. Sa may C2B natin kasi, C2B natin, we have symmetry elements. That is where it comes interesting. The C2 point group contains many symmetry elements, di ba? Na-discuss natin, di ba? We have 3 symmetry elements here na meron tayong E, meron tayong C2, we have sigma V, di ba? So, ang tawag dito ay, ito yung mga symmetry operator natin na nagamit by using C2V. Di ba? The symmetry operations. Ayan, symmetry operations na nagamit for C2V. Ayan, di ba? So, and this one is ang tawag dito ay symmetry representation labels. Symmetry representation labels. And this one, itong mga to ay, ito yung nating character for each molecule. It is useful for vibrational spectroscopy such as IR. And then this one, ito, will tell us kung ito ay either Raman or IR active pa siya at that particular. Of course, you can determine the Raman and IR active by solving the reducible and irreducible representation of a particular molecule. So, next lecture video natin yan. Okay. Also, haba yan, C3V. These are the operations na perform for that. And these are the IR active and Raman active elements natin. Okay. Ganun yan. Na ma-appreciate ninyo in the next lecture video. Okay. I just discussed. Inintroduce ko lang sa inyo. So, makikita nyo to sa mga appendix ng mga inorganic molecules book. Inorganic chemistry books ninyo. May kita niyan, madami yan. There are actually many point groups of that. And then, dito yung parang pinaka-application ng ating molecular symmetries, the vibrational spectroscopy. So, dito natin i-relate yung character table and point group. So, using that, the molecular symmetry topic to determine and predict its vibrational modes in IR and Raman spectra. Okay? So, that's it. That's for the our lecture video for today. I hope you learned something in this lecture video. So, ang tip ko lang sa inyo is if you can't imagine the molecule on a paper, I suggest that you buy yourself a clay in order for you to visualize. And meron din naman nabibili actually sa Shopee. Mas convenient yon. Yun nga lang, it's quite pricey. Pero magagamit nyo talaga if you're going to use it. Talagang it's a ball and stick model. It's efficient. Ayoko lang mag-advertise ng specific brand. Yeah, tignan nyo na lang sa online shopping, okay? Thank you so much, guys. See you on our next lecture video. Um, Thank you so much.